This is going to be a very long video, so to keep it short, I'll keep this opening real short. Did solve the problem with the spindexer and the run out and the 5C collets. You can see behind me I bought the entire 5C collet set. Because when I use this guy, I really want it perfect, and so this works out. So I had a blast making these gears and made 2 of them, and they're working perfectly. So on with the video. See you next Friday. The gears on the second lathe are all of a sudden making a lot of noise, and I'm not sure why, but I'm listening to it as carefully as I can. I think part of it's this gear. There's probably a bunch of them, but I was thinking, you know, let me make the gears. I've seen a lot of other YouTube videos, people doing it. Let me dive into that and see what happens. And I'm looking at this gear, and what I'm seeing is, let me bring out my little pointer here. Pretty cool, huh? Walnut handle. I showed freehanding, how to make round here. Little brass guy, so I thought, you know, pretty cool for pointing out. But this edge here, what's happening is as the teeth disengage or engage, they're ripping up this edge. Because I'm looking at it under the microscope, and it's getting pretty bad. So, and I'm figuring this probably happened. The previous owner didn't take care of aligning the 2 bushings on the lead screw, so it was binding, and it was putting a lot of force on these gears. So in any case, I want to make a gear, so I start basic research. You know, I've seen people, they have cutters. So I went on Banggood, and lo and behold, there's sets. Yeah, I would have thought, you know, it's just one cutter, but no, it's a set. And you look at them, and for instance, this one cuts from 55 teeth to 134 teeth. This one was what? This is anything above 135 teeth. So I got to count it, and I counted them all, and that's a 20-tooth gear. So this was the cutter for it, and you'll see this in the video being used. So yeah, you make an arbor for it, and I do have a lot of run out on this thing for some reason, and this whole video is going to be full circle, and I explain what that is. For instance, this was shown in the video wobbling all over the place, and now full circle I'm going to tear this apart and figure out what's wrong with it. So okay, I've got the cutter, and I've got an arbor, and I'm looking at these, and I'm figuring it's got to be something different. And I'm looking at the angles and all that. I can't visually see any difference in these guys, but I did figure out, and I'm going to start using the dial rather than the digital, because you'll be able to definitely see it. The digital, if I'm not at the right angle, you guys can't see what the numbers are. But I did do this. You know, this guy is, you can kind of see it running around, 159-ish thick. This guy is, boom, less. 48, I guess, 148. So there is a minor difference in these guys to account for, I guess, the outside diameters and stuff like that. So, okay, fine. I put the gears on order, and I'll put a link in the description to them on Banggood. Who else? Oh, eBay also had them. One of these I bought. Oh yeah, it was this guy. The actual one I bought off of eBay. These 2 came off of Banggood. Whatever. Okay, so I've got my cutter, and then now I got to do all the formulas and figure things out. So you go on the internet, and I started doing all the research. I know this is upside down. Where's my pen? Here it is. So I'm thinking about it, going, okay, it's a Chinese lathe. This should be a metric gear, but the mini lathe manual and the chart that's on the side cover only shows how to cut imperial threads. So are these metric gears or imperial gears. You know, you got metric gears cutting and imperial thread. So you go on the internet to research, and if it's imperial, it's going to have a diametric pitch. If it's metric, it's going to have what's called a module. So I found a website with a calculator, which was really easy. Count the teeth, enter it in, measure the outside diameter, enter it in. If it's imperial, you're going to come up with a number like 80, 22. There's a whole bunch of them that's shown in this website. If it's metric, you're going to come up with 0.7, 0.8, 1.0. I came up right on 1.0 exactly, so I guess I did a good job measuring it. So you have metric gears cutting imperial threads. So without a doubt, you know, I double checked it with a couple of the gears. All the gears are indeed metric. So the module, which everybody says mod, is 1.0. All right, so I got that figured out. Now, there's a bunch of different places on the internet showing all the formulas to figure everything out for metric gears. And it, you know, they come up with tooth width and this, and you know, to find this, you measure pitch circular diameter times the sine of. So I run all the math, and I'm figuring it out. And the only thing I care about is I want to know the outside diameter and the depth I have to go. So the outside diameter was simple. It's the number of teeth plus 2 times the module, 22 millimeters, and you measure this, you go, yep, okay, 22 millimeters, perfect. And I ran the formula for the depth, and it says I have to go in, I guess, 3.14 millimeters. So I've got that. Now I make my blank out of steel to those dimensions, and I also use gauge pins to get the diameter here right, so it fits the little screw that it's supposed to go on, that it mounts on. Then I run a test of this guy on just a square piece of steel to see what's going to happen, and it's still super sharp, but because I'm going to have to put this on an arbor and have it hanging out of the Spindex, I'm figuring, you know, with this, how much this is doing on steel, let me make one out of aluminum. So I made a blank out of aluminum. I don't have it here because I made the gear, test gear out of it. And I'm not going to make it out of steel because aluminum, you know, I mean, you got plastic, you got aluminum, you got steel. The aluminum's going to last for a long time. So now I'm going to make it out of aluminum. I got my blank, and I'll show in the video the whole setup to it. And I start machining it, but then here's where where I'm talking like full circle is that the dimensions that they want for depth and tooth width, according to the internet, is a mile off. I mean, they're saying what this gap should be, and I'm doing that, and it's like this size going in here. You're 10 miles off, so I don't get what's going on. In any case, I just flew by the seat of my pants and said, all right, and you'll see in the video, I said, I'm going to call it quits there. Came out really good. Oh yeah, I had also made an arbor here. Here's the arbor for the thing. So it's kind of cheesy. I did it real quick, but you'll see it holds it nicely. What else then? So now it's full circle. I'm going, why are these numbers off? And I start finding each website has completely different formulas. It comes up with different numbers. It's like there isn't an industry standard here. Some people call it circular pitch diameter, some pitch circular diameter. It's nuts. So I pull out, for the heck of it, you know, rather than a machinist thing, this guy, the black book, engineer's black book for metric gears. It does kind of say metric, but it's confusing here. They clearly point out what all the things are, but there's no formulas. So I'm like, huh? I don't know. Yeah, there are some formulas, but okay, fine. Let me try the other book, because this thing is, you know, an engineer's black book. I pulled this one out, which I showed in another video. This is the machinist reference. And you go into this book, and here's all the formulas for everything. For metric, it says clearly metric, calculations metric, module standard. These numbers work. This is whole different. And I had put the caliper on this guy, trying to measure it as best I could, writing down the numbers. I run it here, and it's darn close. I mean, it says the actual depth I'm supposed to go in is 88 thousandths. I'm measuring very close to 88 thousandths for depth, whereas they said, you know, 3.14 millimeters, which is 123 thousandths, way off. And in the video, you'll see I actually quit. I forgot what I called out, but I called out pretty close to 88 thousandths. So this guy has all the formulas. If I want to make, and I'm probably going to make some other gears here. And aluminum was nice too, because I've got plenty of stock for all the different sizes to make these different gears. So that's it for my kind of opening lecture here. And so you'll see what I'm doing. I didn't show every inch of making the gear, but this whole thing is basically, I'm just passing along my learning curve. So hope you enjoy the rest. Just want to share what I'm figuring out here. First, gears are supposed to look like this, where they've got the pressure face and a relief angle on them. And the idea behind the relief angle is as the gears come together, which you can see, as the gear comes together, this relief angle allows the tooth to come in without clipping this corner. Likewise, as it exits, it doesn't clip this corner. So I'm looking at this gear first, which is the one that I make in this video, and I'm described that these corners are just mangled up on this. And I was wondering why, but I go and look at the gear that this mates with, which is the big gear that's mounted on the actual spindle, and lo and behold, that gear does not have the relief on it, so it's not really made correctly. So as a result, it's clipping these corners as it comes in, and it's tearing it up. So that's the first thing that I want to say. The second thing is, in the video I mentioned this gear is what I'm suspecting to have a lot of noise to it. This is that gear. I took it off the lathe and I'm looking at it. Lo and behold, it doesn't have the relief angle either. And I go and look at the plastic mating gear, and it's starting to tear that gear up also. But okay, on these guys, why are there sets? Well, I measured them, and yeah, they're different thicknesses. So if you think about it, you can't really change the pressure angle. It's supposed to be 20 degrees for the metric gears here. And you don't really want to mess with the relief angle either. So the only way to have the correct number of teeth equally spaced is to change the space here. So these guys are different thicknesses so that you have more or less space between teeth to make it evenly come out on the gear. So you can't really see it because it's only a few thousandths. I only have, what, 1, 2, 3 pieces. So it'd be interesting to kind of try to measure that, which you can't get down in there on these small gears. So that's the next thing. There are sets because they're different thicknesses for doing different numbers of teeth per diameter. Next, I'm beginning to wonder, you know, I'm only going in 80, 90 thousandths, so I'm not even coming close to this surface. I'm out here. So I'm wondering what is cutting this surface and what's cutting this angle here. Staring at it, suddenly I tuned in on it. This angle here is different than this angle here. So, and if I stood it up, and I did, and I put an angle gauge or protractor on here, yeah, every other tooth is one angle and every other tooth is another angle. So again, you can't really see it, but one tooth cuts here and the next tooth cuts this, and then the next tooth cuts this again, and then that. So you really don't want run out in this thing, and I did fix the problem that you'll see here in the video with the arbor wobbling and run outs because Dave didn't bother to really inspect and clean up the arbor and the cutter itself. So there's sets for thicknesses to space it out, and every other tooth is doing its job doing the cutting. And here's the blank. I'm waiting for the cutter now to be able to do this gear. So hopefully things will get better when I've got the correct gear with the relief angle in it. Sorry if there's any glare here. Doing the best I can looking in the monitor at it. This, let me tell you, has been a real pain or intense thing getting to this point. First thing I did is I know there's a lot of run out in this Spindex, because I've tried to do hex heads before and it's just, it's nuts. So I had put this on the granite plate first and with a test indicator up on this to see what the run out is, and lo and behold, as I'm pressing on this base, the whole thing is rocking. So the bottom of it is not flat. So I had no choice but to actually do this on the granite plate. I put sandpaper down there, WD-40 on it, run it around a few times. Lo and behold, it's now flat. Next thing I did was I was trying to do the test indicator on this, but this guy just kept moving. So let me do it with it on the mill, bolt things down. To be able to get this guy to clear the jaws, I had to come up pretty high with the Spindex. Normally I just put it on parallels, but that was too low. So I'm on 1, 2, 3 blocks. Longer bolts I had to make. Got it bolted down, eyeball it to get it squared up. I don't think it's too critical, but I'm there because I can eyeball this whole edge here to the DRO scale that's on the back, and it's like perfectly straight. And looking at the whole thing here down the middle, it looks like it's square to the jaws and so on. So now I've got it bolted down. I got it to a height that I can use. And I've got 5 thousandths here. 5 to 6 thousandths going Y. So I know this is accumulated error. I got error here, and I've got error in this collet. But yeah, the other thing was this was a long rod, and it wouldn't go all the way in because the chuck doesn't have a hole all the way through it. So I had to cut this off, and I was afraid when I got it up here trying to clear, not hit this guy, but do the full cut, I might have made it too short. So I've got it out as far as I can, and you can see I've done some cutting, so it's solid enough to do this so far. I haven't gone down very deep. So test indicator, forget that. I pulled everything out. I'm checking this guy inside. No movement at all. So it appears like it's perfect. The collet, I double check everything on it, deburr it, put it in there, test indicate this. I've got 5 thousandths run out. I look deep down in here and there's dirt all over in the back. So clean that all up, put it in there. And now I'm down to like 3 or 4 thousandths. Tried Stefan Gothman's trick where you tap and try to move. I've got it down to about 2 thousandths. So I'm going to live with that for now. When I'm done with this gear, I'll put this back on the granite plate, figure out where the problem is. I think it's this 5C collet. It's not made right. So, okay, according to the print, every 18 degrees, I made my first pass on it. It's actually starting to look like a gear, pretty cool. I was doing the Spindex backwards. For 16 degrees, I'd move it, you know, here, and then I was going this way with the pin rather than going the other way with the pin. Luckily, you know, it's just, this is why you do scratch tests. What I'm about to do, yeah, 360, you can put it over there. All right, what happened here? Why aren't you coming out? There you are. So I can go back to 0 degrees, and I've got the y-axis DRO set on millimeters so that I know what I'm doing and how far I'm going in. So, oh, I never locked the table. All right, I'm gonna take it in. Oops, I'm not in the right mode there. There I am. All right. I'm just going to make another little bitty cut. I just said 5 thousandths, which is still 0 millimeters. So, all right. I'll just do one cut for you guys so you can see it happening. All right. So I'm set for 0. There's that. Turn motor on and go in and make one cut. I do have a lot of wobble in this. I haven't bothered to fix that, but so there it goes. And I just go in and then back it out. Wow. That's coming close to hitting this nut. Oh, I also tried, I've got a different nut on here in case the nut was causing a problem. So it's kind of cool, and it's going to take a long time to do this. Thought I'd show actually doing this for a minute. I'm in, oops, 43 thousandths. This will be 43 thousandths. The calculations say I got to go in 2.4 millimeters. I'm almost, this will be like 1 millimeter now. So I set the calculator 18 plus plus equals. So, I guess you can't see what I'm doing. Oh, there, I'm on 0 degrees. So, it's doing a nice finish. I mean, I think it's doing pretty darn good. I'm up pretty good in RPMs. Seems to be pretty solid. It's taking it nicely. So, this is getting pretty deep now. 0 degrees, and go 18. So pin's gonna move 1, 2, 3, 4, 5, 6, 7, 8. Rotate it past the 1. There's 18 degrees. And then top, see how close I'm coming to that nut. Pretty close. I'm hoping I can hit depth without having to mess with anything here. Alright, 36 degrees, 2, 3, 4, 5, 6. Past the 3, 36 degrees. It's kind of cool. That's really looking like a gear, you know. I'll eventually have to stop it here and actually see how close I'm coming to the collet nut. And I just hit equal on the calculator, gives me the next one, 54 degrees. 2, 3, 4, pass up to 5, boom, lock it, and there it is. So, I thought it was going to take longer. You actually get pretty good at it once you get a routine going. Equals 72 degrees. I probably could put some tape up here to make it faster for me to know where the 2, 6, and 8 are, because it's just repeating itself over and over again. Then be 90 degrees. So go to 90 degrees. There we go. A quarter done with this, huh? May have to take the other gear off and double check calculations as far as this depth I have to go. equals 108. 2, 3, 4, 5, 6, 7, 8. Go past the 1, boom. So that's kind of it so far. I guess you can see it's looking pretty nice. 126. 2, 3, 4, 5, 6. And oh, I do that a bunch of times. Don't come back far enough. Doesn't matter. I'm going to do a big chamfer on the edge here anyway. So that's kind of it. Bring it back when it's close. I'm going to call it quits at this point. The metal gear on the lathe, I'm just putting this in there going, it's just under a 1/10, 100,000th in. What am I at right now? According to the scale, I'm in 84,000, which is, nope, that's not millimeters, 2.13. So they want me to go in a little bit further. I'm not going to do it. I mean, you can see it looks pretty darn good. Let me pull this pin out. So it looks like a gear. And this flat spot that's here looks like the same size as the flat spot on the metal gear on the lathe. So can you make a gear on a mini mill? You sure can. And it comes out pretty darn good. So I'll have to put this in the chuck spider and then I guess do some pretty heavy chamfering because it chewed this side up. But the finish looks gorgeous in there. What have I got to take this off? Oh, I need a wrench. Here, out of the drawer and take it off. Let's see what this sucker looks like. Lock this in place. There it is. Scary, but that's the end of it. Locked out too as far as depth. I never hit the collet nut, but wow, that is pretty hot looking, huh? One gear. That is awesome, boy. Oof. It'll be fun to try this guy. So, hope you enjoyed. Looks like I got it right on the money. There's no play. Because these are fixed. You can't adjust them on their mesh. And that's like perfect. And even the top guy here, when I engage that, there it is. It's right in there. I don't see any play, movement, anything in there. That is beautiful. I think this is the one making all the noise, so I may have to buy the guy for that. Let's see, everything's free. I can start this guy. Yeah, look at that. That is nice. Is it quieter? It's a little bit quieter. So I have no idea how I'm going to make that because it's 25 teeth and that doesn't divide into the spindexer. If I can make that one, I will. I'll probably have to order the cutter for that. But wow, I am very happy with the outcome of this.